All right, good morning. So in the last class, we were talking about this function strtok, right? So that's the string tokenizer function. So remember, that's the function that can take a string that contains some kind of delimiter character, right? And that separates fields or tokens or information that you're interested in. And it will break that string apart, one token or one field at a time. So it turns out this is extremely common when you're working with text files that contain data of some kind. So every common spreadsheet program will import or export a comma-separated values file. So that's just the value in each column printed as a string, followed by a comma, followed by the next column, and so on and so on and so on. If the strings contain spaces, then normally, well, it depends on the file format. Often it'll be quoted or double quoted or something like that. Tab-separated values are also very common, so you'll have fields that are separated by one or more tab characters. Those are common in, and there's colon-separated as well. So the colon-separated are common in database, for databases that export their data as some sort of text format. So this is actually quite common that you need to do something like this. All right, so we're going to talk about input and output today, and hopefully by the end of this lecture, this will get you through the last assignment. All right, so input and output. So that's reading something from somewhere and outputting something somewhere. Right, so that's input, reading data. Output is writing data. Now, there's a few different ways you can do this in C. So you can work at a very, very low level where you basically read and write individual bytes. Right, so 8 bits, but that's awkward to use. It's a little awkward to use. Instead, we're going to talk about a higher level way of doing input and output. All right, so stream in C is just a source or a sink of characters or bytes. Right, so if it's characters, then it's some sort of text-based stream. Right, so when you're typing something into standard input, that you can think of that as being a stream of input where the input's coming from the keyboard. Right? If it's a stream of bytes, then it's binary data of some kind, and then it depends on what the binary encoding of the data actually is. We're only interested in text-based data. All right, so in C, the easiest way to deal, I guess the highest level way of dealing with streams is with this type called big F file. Right, so all caps file is the type. Right, so file is it's an opaque type, so you can't actually see what's in it. Right? But a file object stores all the information that's needed to control an I/O stream, right? So an input or output stream. The structure, or exactly what's in this thing, depends on your operating system, your computer architecture, and your compiler. Right? So the standard doesn't say anything about what's actually in this thing. Right? So as a user of this thing, you're also not supposed to know what is inside this thing. So when you're using this thing called file, you're always accessing it through the standard library. Right? So that's in the I/O. That's in the I/O part of the standard library. So that's going to be in some of the stuff in string.h, and some of the other stuff will be in standard IO.h. Okay, so the software manual for the compiler most of you are using says this about file. Right, so file objects are allocated and managed internally by the input-output library functions. Do not try to create your own objects of type file. Right, let the library do it for you. Right, so your program should deal only with pointers to these objects. Right, so everything's always a pointer to file rather than the objects themselves. So this is exactly the way that we're using, that we did the stack type and the list type. Right, you're also going to do this with the file type. Everything's a pointer to a file. When your C program starts to run, if it's on a hosted execution environment, so in other words, if it's a regular computer, you get 3 streams for free. Right, so the standard in, standard out, standard error. Right, those are the exact same streams as in Bash. Standard error is normally hooked up to the keyboard. Standard output's normally hooked up to the terminal. Standard error is also normally hooked up to the terminal. Right? It's exactly the same as in Bash. Just like in Bash, I/O operations are usually buffered. right? So that means, so when you try to read something or write something, normally the read operation causes data to be written into an array somewhere that you can't see. Similarly, when you write something, normally that data goes to an array somewhere you can't see, right? And then when the system is ready to deal with the data, it actually performs the rest of the read. So then it actually brings in the, it either inputs or outputs the data. And this is done because normally when you read or write something, compared to your CPU or to memory, reading and writing is very slow, right? And so it's useful if the computer, if your operating system can ask for data from the disk, your computer can then do something else while the input buffer fills up, right? And then when the input buffer is full, the information is transferred to the CPU, right? So the individual streams all have their own buffers, or are allowed to have their own buffers, right? The standard input has its own buffer, standard output has its own buffer, standard error may or may not have its own buffer. Okay, so your stream can be in one of three buffered states. So it can be unbuffered, which means there is no buffer. So as soon as you ask for a read or write operation, that operation happens immediately. Standard error might be unbuffered because if you're outputting something to standard error, you probably want to know right away there's a problem, right? So you don't want to wait to fill up the buffer before printing a message. But it may not be, so it may also be buffered. Again, it depends on your operating system. It could be fully buffered, so that means the operating system will wait till the buffer is full before it transfers data. So you ask to read something, it'll wait till the read buffer is full before the data gets transferred to you, right? If you write something, it'll wait till the write buffer is full until it writes. You can also, the programmer can usually also explicitly flush the buffer. And so they can force the buffer to be read or written. And finally, it might be line buffered. So line buffering happens when it waits till the buffer, it waits until a new line character appears in the buffer. Right? So data is transferred as lines, right? Where it's delimited by a new line character. So for example, when you type something into your terminal, you press enter. That might be an example of line buffering, right? It waits until you press the enter key before something happens. So to use a file object, you have to open a file. So you have to create a connection to the thing that you want to read or write to. Right? Now you don't have to open the standard streams, right? So you can always read from standard in, you can always write to standard out or standard error. Right? So they get open for you when your program first starts. If you want to, you can close them and send them somewhere else, but we're not going to talk about that in this course. Right? If you want to read from a file, then what you do is you create a connection to the file by making a stream, and that function is fopen. Right? So you call fopen, you pass in the name of the file that you want to open, and then you pass in a string that controls what are you going to do with the file. Right? Are you going to read to the file, are you going to write to the file, or are you going to do both? Right? If this succeeds, you get a pointer to one of these file objects. If it fails, you get null. So for example, if you try to open up a file that doesn't exist, fopen will fail, and you'll get null. If you try to open up a file to read, and you don't have read permission on it, it'll fail. If you try to open up a file to write, and you don't have write permission on it, it will fail. Right? So you always want to check the return value of fopen to make sure that you actually have a connection to the file. Okay, so we're only concerned with the first three rows of this table for now. Right, so when you open up a file, you pass in either R, W, or A, right, for read, write, or append. Right. So if you open up a file for reading, and if the file exists and you can read it, then that will start reading from the start of the file. Right. If the file doesn't exist or you don't have read permission, you get null back, so it fails. If you open up a file for writing, if the file already exists, then the contents of the file are destroyed, right? And this happens immediately. So as soon as you open the file and for a write operation, you can consider your file, your current file, to be gone, right? It's going to overwrite whatever's in the current file. If the file doesn't exist and you have write permission on the directory, the file will be created new for you. So you get a new file and a new empty file, and writing will start at the beginning of the file. You can also open up a file for appending. So that's writing to the file, but it always writes to the end, right? So unlike write, where it writes overwrites or writes from the beginning, we always start writing at the end. If the file doesn't exist, it makes a new one for you. Okay, so whenever you open a file, that allocates system resources, right? So in Linux, you end up with, actually in any operating system, the operating system has to keep track of what files are open, right? So there's a limited number of streams that your operating system has, that your operating system makes available to an ordinary user, right? If you run out of what are called these things called file handles, then you can't open up any other files. Right now in Linux, that's a problem because as far as Linux is concerned, everything's a file. And so that will likely cause your operating system to stop being responsive. Right? So if you open up too many files, there's going to be a problem. If you open up, if your program repeatedly opens up a file and doesn't release the resources for the files, you will eventually end up in a situation where you can't open up any more files. Right? So you will exhaust the operating system resources. So when you're done with the file, you should always close it, right? So you just write fclose, pointer to the file object that you are done with, and that will close the file stream, right? If you're writing to that stream, then the any unwritten buffer data gets sent to the is delivered to the operating system so that it can be written to the file. If you're writing from that stream and you close it, if you're reading from the stream and you close it, then any unread buffer data is discarded, right? So as soon as you close the file, you don't have access to it anymore. So it does return an int. So technically, it can fail. If it fails, it returns this value called EOF, which I think is a negative value. I think. I'm not 100% sure, but it returns this value called EOF. Now, if closing a file fails, there's nothing you can do about it. Right? So the programmer doesn't really have any control over, doesn't have any control, or there's nothing they can do to fix the problem, right? This is an operating system level issue. So normally no one checks the return value of fclose. If you call fclose, then the stream that's associated with the file is no longer accessible, or is no longer associated with the stream, even if it fails. So if it fails, you can't do anything about the stream anyway, right? So normally the return value is not tested for anything. All right, so we can open a file, we can close a file. Before I show you how to use them, we have to be able to do something with the file. So let's read in one character at a time in the file. Right, so fgetC is one of the functions that you could use to read a single character from a file. Right, so it reads one character, and that's it. Right, it returns the character as an int instead of a char for historical reasons. If it fails, so can't read the stream, can't read the file, or if you're at the end of the file, it will return EOF on failure. Right, so that's just some constant value. It's short for end of file, but it's not always the end of file that causes the failure to happen. Right, so for example, you could, while you're assuming you can read the file to begin with, while you're reading it, someone might you might have taken away permission on the file, right, for reading. So that would cause a read error. You might delete the file accidentally, so that might cause a read error. You might move the file somewhere else, right, to another file name. That would cause an error as well. Okay, so here we go. So here's a little program that reads one text file, one character at a time, right? It simply prints out what it reads. So this is basically cat, right? This is a simple implementation of the cat program. So I'm going to read the file temp.txt. Right? Now, normally you would have a command line argument here, right? You'd take the file in from the command line argument. But to fit it on this slide, I'm just going to read in temp.txt. Right? First thing you do, establish a stream to the file. So fopen, right? Pass in the file name. We want to read, so I'm going to use R as my mode. Right? Always test the pointer that you get back. Right? So if it's null, print out some kind of error and probably exit. Right? Otherwise, we're just going to read this thing in one character at a time. So I'm going to write a little while loop. While loop's a little funny. So while, So I'm going to use fgetC, right? Pass in the file pointer and store that in the variable C. Right? Now remember, in C, assignment produces the value. Right? So I'm going to wrap that in round brackets. Right? So what this does is it calls fgetC, right? Reads a character from the file, stores that in C. Right? The value inside the round brackets, the value resulting from the round brackets is the value C, right? The value that's read in from file. Right? So this says as long as the character that you read in from the file is not EOF, right? We're just going to write the character to the standard output. So putchar is one of the functions that you can use to write a single character to standard out. Right? So read from the file, write standard output. Right? Eventually you'll get to the end of the file. Right? And so fgetC will return EOF. It'll stick that into C. Right? All of that will be EOF. Right? And so now your while loop will stop. Right? When you're done with the file, don't forget to close the file. If you exit from a program with an open file, the operating system will close the file anyway. Right? So I'm just showing you this here because this is what you should do. Right? If you forget this line in this particular program, it's not a big deal. The operating system is going to clean up anyway afterwards. Right? Okay, so we're going to run that little program. So we're going to reading temp.text. So let's see what's in temp.text. Right? So I've just got one string in that file. Right? So I'm going to do read car, I think. What do I call it? Read file. Okay, read file. There you go. Right? So it reads the file one character at a time, outputs each character it reads. Right? If you stick in some new lines, that's no problem. Right? So this is just one line long, but if you add in some, here's another line. Whoa. Right? That works just fine. Right? So the new line character is just a character. Right? When it reads it in over here, after the period, it just prints a new line and goes to the next line. Right? So basically, I mean, you've got a minimal implementation of cat with that little program there. All right, so remember the pattern. Open the file, test. Is the pointer valid? Right, do something with the file, close it when you're done. All right, so instead of reading individual characters, you can read in entire lines. Right? So line-oriented data in text files is very common. Right? It's very common to have formatted information of some kind, one line at a time in a file. Right? And so fget is one of the functions that you can use to read in or to attempt to read in a line of a line of a file. So the way this thing works is, well, you call fgets. Right? It returns a pointer to a car, so it returns a string. Right? You're going to store the string in str. Right? So it's going to try to read the one line of the file. It would like to store it in str. Right? It's going to read from that file there. Right? And at most, it'll read that many characters minus 1. Right? So you need this count parameter here, right? Because you don't really know how long. You may not know how long each line of the file is. Right? And you need some sort of string to store it in. Right? So this count parameter is here to make sure that you don't overwrite the end of str. Right? Fgets would like to write in the null terminator every time, if it can. So that's why it always writes. Reads at most count minus 1 characters, because it wants to write a new line character at the end of str. Right? Okay, so fgets will read up to Will read up to a line character if it can. Right? If the line is longer than count, minus 1, I guess. And it doesn't reach the new line character, it still stops. So what that means is you're going to be left with whatever is left on the line in your file. Right? So it's going to read up to count minus 1 characters. If there's more characters, then the next read or write operation is going to start at that point in the file where it left off. Right? So you'll still have part of the string, part of the line waiting to be read. if fgets does read to the end of the line, you get the new line character at the end, right? So it's your string, new line character, null terminator. Often you don't want that new line character, so you have to get rid of it manually. On success, you get a pointer to str. On failure, you get back null. So failure, again, occurs if there's some sort of read failure. Sorry, question? Yeah, the return, yeah, you have to remember fgets always leaves the new line character, always copies the new line character into the string. Okay, so here is more or less the same program as before. This time we're going to read one line at a time. I think the version I'm going to show you also takes in the argument from the command line. Okay, so we're going to open up some file. Right? So open the file. Test is the pointer null. Right? Now here I've got a string that can hold 99 characters. Right? And so when I call fgets, I'm going to pass in 100. So it'll read at most 99 characters. So this means that if I really want to read one line at a time, the length of the line is limited to 99 characters in the file. If it's longer than 99 characters and you really want to read in one line at a time, you have to do some sort of dynamic memory allocation with this buffer here. Right? So in other words, you have to expand the size of the array in which the string is stored. Right? So you'd have a malloc here, right? And then you'd have to do something funny in here. Okay. So fgets returns a pointer, right? So it returns null if it fails. So when it gets to the end of the file, it's going to return null if you call it again, right? So we can simply write the loop like this, where fgets is the condition, right? So when it returns null, this loop will stop, right? And this will just echo out or print each line of the file one line at a time. Once we're done with the file, we'll close the file. So I think the program I have here is, not this one, read lines. Okay, so this one actually takes it in from the command line. Right, so here I'm going to check, right? Now remember how argc works, right? Argc is the number of command line arguments plus 1, where the plus 1 is the name of the program. Right, so this program expects a file name, so I'm going to check if argcount's not 2. Right? So if it's not 2, I'm going to print out my little error message. Print it to standard error, right? So fprintf will print a string, a formatted string, right? Fprintf is exactly like printf, except you print to a specified stream instead of standard output, right? So to print a standard error, you call fprintf, passing in standard error as the stream. Right? That's going to print out my error message there, right? And then exit here, right? Otherwise, it's exactly the same as I showed you before. Oh, sorry. The file name is stored in the second command line argument, right? The first command line argument is the name of the program. So the file name is in the second command line argument, and now the rest of the program is the same as before. This is read 5. Sorry, which one is? I think it's read lines. Actually, which one is this? Let's see what happens. Temp.txt. Okay, so that one works, right? So it reads in that line, right? Prints the line, reads in that line, right? Assuming the lines are 99 characters or less. Oh, okay. So happily on the assignment, you are told that there is a maximum line length that you have to deal with, right? And so that simplifies your life a lot. All right, any questions so far? Okay, so you know how to read in characters, you know how to read in lines of text. What do we want to do next? I guess I should show you how to read in formatted text. So let me just quickly look at what the next deck of slides looks like to see if it's appropriate. Is it this one? So there's fgets again. Here's gets. I'm going to jump to code and show you a little program instead. All right, so the assignment is set up so that you read in formatted data. So it's set up to, you have to read in a comma separated, so you have to read in a file that has multiple lines. Each line consists of a comma separated list of integers, right? And so it doesn't reading it one character at a time isn't really the greatest way to do it, right? You could do it one character at a time, and you could try to build the ints up as you read them, right? So you might read a 1, then a 5, then a 7, then a comma, so you know that the first int is a 157. That's awkward. It's doable, but it's a little awkward, right? You could try to read in the whole line at a time, but then now you're, and then split the line using strtok. So that works in this assignment. The other way to do this is to use the function fscanf. So fscanf will read from a file formatted data, right? So the formatting, it works similarly to how fprintf works. You pass in some string that contains a bunch of conversions in it, and then you pass in pointers to variables where you want to store the converted values. Right? Okay, so here is fscanf right there. Right? So we're going to read from the file pointed at by f, right? And we're going to try to read in one int value there, right? So %d, right? If we read in the value, we're going to store it in the variable val1, right? Now remember, for the function to write into val1, it needs a pointer to val1, right? So that's why there's a pointer here, right? All of the, what are these called again? There's a name for this. All of these arguments here are pointers to something, right? So you have to point to somewhere in which it can write the data into. Now the way fscan works is a bit funny. So if you're reading something like an integer, so if you use %d, or if you're reading in a floating point number, so %f, or a string, it will skip over any white space before it starts to read. Right? So you have space, 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 5. It'll skip over all the spaces and then read the 5 if you pass in %d. Right? It'll stop reading as soon as it sees another space. Right? So space, 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 5, 7, space. It'll read in 57 for the integer. Right? That's true for strings. It's true for floating point numbers. Right? So that means you can't use fscanf with %s to read in a string if it has spaces in it. Right? You have to do something else. Okay, so this will read in, fscanf returns the number of conversions that were successful. Right? So here there's only one conversion. Right? So fscanf here hopefully returns 1. Right? So it returns an integer value equal to the number of conversions that were successful. Right? You can have multiple conversions inside this string here. Right? What is, sorry, I just want to see what's in simple text. Okay, so 99, 2.5, and hello. Fine. Okay, next line here. So here it's going to try to read in, so LF is a double, right? So F is floating point, the L modifier makes it a double, right? So it's going to try to read in one double value and write the value into val2, right? If you go back to the file, right? So we have an int, then there's a new line character sitting there, right? fscanf skips over all the white space. So it skips over the new line and then tries to read in the 2.5. Right? There's another new line character here, which is a space character. So it's going to stop reading after the 2.5. Right? And then %s, that's a string. Right? Next it'll try to read in a string. Again, it's going to skip over any white space, and it'll stop when it sees white space. Right? So if this works, it's going to print out the integer, the floating point number, then the string using printf. Okay, rewind. So when you read a file, the way that it works is it always moves forward through the file, right? So what I've shown you so far, you can't go backwards in the file, right? So read in something, it moves forward in the file, right? Reads in something, moves forward. Then it starts, the next read operation will start at that point, moves forward. Next read operation starts at that point and moves forward, and so on and so on and so on. If you finish reading a file and you'd like to read the file again for some reason, you can rewind the file. So rewind goes back to the beginning of the file so that you can read it again. Right? You might ask yourself, why do I want to do this? Right? So imagine you're trying to read in a file. You don't know how many lines are in the file. So one thing that you can do is you can read in, you can attempt to read in all the lines or read in all the new line characters, right, to figure out how many lines are in the file, right? And then you can do something now that you know how many lines are in the file, right? So now rewind and go back to the beginning, and now you can read everything in, perhaps storing stuff in an array of the appropriate size. Right? So I'm going to rewind the file, and then I'm going to read the file again. This time I'm going to do it in one shot. Right? So rather than reading in an int, then a double, then a string, with 3 calls to fscanf, I'm going to use 1 call to fscanf. So like this. Right? So you can have as many conversions as you would like inside the string, inside the conversion string. Right? So I can do %d space %lf space %s. So read in an int, right? Skip over any white space. That's what the space means here, right? Read in a double, skipping over any white space. Read in a string, skipping over any white space, right? Store the value, store the int in val1, store the double in val2, store the string in str, right? Notice str is not address of str here, right? str is already a pointer, right? So it's already an array in this case, right? So str, the name it's on its own, is synonymous to a pointer to the first character of the array, right? So here you're not taking the address of str, right? You can just pass in a pointer to the first element of the array, right? And that will also read in. So that should give you back 3 in this case, right? Because there are 3 there should be 3 successful conversions in this case. So this is, what is this called? fscanf demo. Right. So the first time it goes through the program, right, it reads in 1 int, reads in 1 double, reads in 1 string, prints the int, prints the double, prints the string. Right. The second time, we're going to read all 3 values in 1 call to fscanf. So now it reads in 3 values, the int, the double, and the string. Now, the formatting string is allowed to contain stuff other than conversions. Where is it? Where is it here? Here. Right? So it is allowed to contain stuff that's not spaces or conversions. So I'm going to edit this file here. So we're going to add a line to this file. So I'm going to do, well, I'm going to do the assignment. 1, 2, 3. Okay? So you have to read in something like 1, 2, 3. All right, so all the way at the end of the program, let's make 3 int variables. So int val1, no wait, int I1, I2, I3. I haven't shown you this either, but you can declare multiple variables on the same line with the commas separating them. That's legal. Right. So here I'm going to do n equals fscanf. All right, so I would like to read in an int, so that's %d. Right, now I know these are comma separated, so I can write a comma here. Right, so %d comma, so it's going to try to read in an int, followed by a comma, followed by an int, followed by a comma, followed by another int. Right, I would like to store the values in I1, I2, and I3, like that. Right, so you can your formatting string is allowed to contain plain old text. Right, the plain old text has to match what you're reading from the file in order for fscanf to continue. Right, so if this works, there will be 3 successful conversions. Right, matching the commas does not count as a conversion. Right, so here n should be 3. Assuming I did everything correctly. So I'm just going to print I1, I2, and I3. And of course, I guess I should do this as %d, %d, and %d, like that. Right. Compile. -o fscat. Come on. Whoa. What just happened here? Passing argument 2 from incompatible. bum, bum. Oh, yeah. My bad. It's complaining that, come on, go away. All right, so it's complaining that it's expecting a pointer to a file. So I'm missing the F, right? Instead, it saw a string. If you've been lucky so far and your programs haven't had very many bugs, that's good. But notice the warning or the error messages from the compiler in C, you actually have to you do need some effort to actually read the warning or error message in order to figure out what's going on. Right, so here the original problem happened on line 30, which is what caused the entire problem. Right, expecting a pointer to a file, instead it got a pointer to a car. Okay, much happier. There we go, right? So now we get the values 1, 2, and 3 at the end. Okay, now you're definitely ready to, oh, you're almost ready to do the assignment. All right, so when you do the assignment, you can either use fscanf to read in the values. You need one more piece of information to effectively use this. The other way to do this is to use the string tokenizing function, which for the assignment might be a little bit easier. You need to know one more piece of information, which hopefully is in this deck of slides or the next. Right? All right, so where are we here? Okay. So I guess now is a good point to jump to writing stuff. Right? So we know how to read stuff. It might be nice to know how to write stuff to a file. So there's an fgetC to read a character from a file. There's an fputC that will write a character to a file. Right? So it writes the character ch to the file pointed at by file. So here the file has to be opened for reading or appending. Right? Oh, sorry, there's a typo here. So there's an fgets that reads in a line of text. Fputs will write a string to a file. Right? So fputs, that string reads str, writes str to that file there. There's no new line character here. If you want a new line character, you have to put it as part of the string. Right? And finally, there's an fprintf. Right? So just like printf, this works exactly the same as printf. Except you pass in a file stream, a pointer to a file as the first argument, right? Otherwise, everything's the exact same after that. You pass in a conversion string, and then you pass in the arguments that you want to convert and write, right? So that's exactly the same as fprintf. Right. So open a file. You really should test the pointer here, but I'm not going to because it doesn't fit on the slide, right? Here we're going to open up for writing. I'm just going to use fprintf for all of these. So we're going to print to the file f. Right? There's your formatting string, so you can have any text you want in the formatting string. Right? The regular text appears as the output, in the output. Right? %c converts a character. Right? So that's the character to convert. So that's going to write the a into here. So it's going to write car, space, 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 colon, space, a. Right? %d writes an int. U is unsigned. LD is a long int. F is floating point. Printf is weird. It's a little bit different than fscanf. So fscanf, this should be LF for a double. For printf, you can just use %f, and that will do float or a double. %s is a string, right? And again, just like printf, you can pass in multiple conversions if you like. So character, followed by a double value, followed by a space, followed by a string. Right. And I actually don't know what program this is. Sorry. Is it here? Write formatted. Okay, so that runs, doesn't produce any output, but that's because all of the output's going to formatted.txt. Right, so if we look at formatted.txt, right, there's your output there. Right. Okay. All right, for the assignment, this is not relevant, but I should talk about how this works for writing to a file. Reading or writing from a file. Okay, so when you read or write to a file, there's the notion of the file position. Right? So you can imagine that your file is just this giant array of characters. Right? The file position is the index in the file. Right? So for every open file, there's something called the current file position. That just points at, or I guess it points at, sure. It points to where the next character will be read or written from. Right? So the file position starts at the beginning of the file when you open it, if you're reading or writing. Right? So its file position would be 0. Right? In Linux, it's equal to the number of bytes from the beginning of the file. And really, you can just think of this as being an index. Right? Every time you read or write a single character, right, the file position moves by 1. If you write a string of length n, it moves by n. Right? If you read something that happens to be 5 characters long, it moves by 5 characters. Right? Ordinary files. Okay, so you can, for our purposes, you can read or write at any position in the file. Right? The weird thing that you can't do is you cannot insert or delete from the file. Right? So you can write whatever character you want at any position. You can replace whatever character you'd like, but you can't insert a bunch of characters or you can't remove a bunch of characters from the file. If you open up a file for append, then appending always happens at the end, right? So whenever you write to the file, it always writes to the end, right? Even if you change the file position to go somewhere else, right? So it's a little bit weird when you open up a file for appending, right? If you open up a file and you append and read, then the read operations obey the file position, but all the appends happen at the end. So that's a bit odd, right? To work with the file position, there's these are three of the more common functions that you can use to manipulate the file position. Right? ftell tells you what the current file position is. fseek will move you to a specified file position, and rewind puts you back at the beginning of the file. Right? So ftell, pass in a pointer to a file. That will give you the file position. Right? Ignore this. This only matters in Windows. Right? In Linux, all files, whether they're text or binary, are treated the same. This returns the file position in Linux. Okay, so here's a little file that I would like to read. Right? Consists of 1, 2, 3, 4, 5. Now remember, there's a new line character here. Right? So each line has 6 characters in it. Right? So 6, 12, 18, 24. I don't remember. There is a new line here. So there's 24 characters in this file. Right? There's nothing after this line, so there's the file ends right there. Right. So the file position varies from 0 up to 25 in this. 24 in this case. Right. So from 0, 24 is here. Right. So I'm going to open up that file for reading. Right. I'm going to get the current file position using ftell. Right. So so this should be 0 to begin with. Right? Now I'm going to read the file 1 character at a time, exactly the same way as before. Right? Every time I read in a character, I'm going to print out the file position. Sorry, I'm going to print out the character, space, colon, space, followed by the string position, space, equals space, followed by the file position. ftell returns a long value. So when you print it, you should use ld as the conversion. Right? D is integer, L is a long integer. Sorry, LD is long integer. Right? So it's going to just print out the character, its position, and then a new line character here. Right? After printing the character, we're going to call ftell again to get the new file position. Right? So remember, every time you read in something, right, if the read's successful, the file position will change by, in this case, 1 character. Right? Because you read in 1 character. So that should go up by 1 every time. Okay, so there you go. Right? So the A is at position 0, right? The E is at position 4. Notice there's a funny blank line here, but that's exactly correct, right? The new line character is at position 5. Right? So F through J new line at position 11, right? K through O, new line at position 17, right? Oh, I guess it's position 23. Sorry, yeah, position 23 is the last character in the file, right? P through T, new line character at position 23, right? And that's the end of the file, so the program stops. Okay, so rewind will, as I told you before, rewinds the stream so you go back to the beginning of the stream, right? And so this program just runs forever, right? So we're going to do the exact same thing as before, right? Read in one character at a time, print the position, right? When we get to the end of the file, I happen to know that position 23 is the end of the file, right? So when we get to that position there, I'm just going to rewind the file. So go back to the beginning. So this just prints out, this just loops forever, printing out the characters of the file. Right? And I think it's called tell forever or something like that. Yes. Right, and so it goes forever, right? So it's an endless loop. Control C will stop it. Okay, so this is a good place to stop. This is going to take a little bit of explanation. All right, so I think you're set for the assignment if you haven't already done it. I guess in the next lecture, if you want to try to do it with fscanf properly, well, sorry, if you want to try to do it with fscanf instead of instead of strtok, I'll show you how to do that one last piece in the next lecture.